An aluminum rod of length 1.8 meter at 10 degrees C is heated to produce a difference in length of 0.007 meter. Calculate the temperature to which it is heated. And then we are given linear expansivity of aluminum as 2.3 times 10 raised to power minus 5 per Kelvin. Now, for us to solve this, we can start by writing out the given parameters, that's the given quantities. So if you check the question now, we are given the original length or the initial length of the rod, and I'll call that L1, and that is equal to 1.8 meters. And then after that, we are given the temperature, that is the initial temperature. I'll call that theta 1. Theta 1 is equal to 10 degrees Celsius. And then we are given the difference in length, which is like the change in length. So the difference in length also means the change in length, and I'll call that delta L. Delta L is equals to 0.007 meters. That's the difference in length or the change in length. And then we are also given the linear expansivity of the rod. That is, the linear expansivity of aluminum is given as alpha, and that is equal to 2.3 multiplied by 10 raised to power minus 5 per Kelvin. And then finally, after listing everything from the question, the last one we have to add is to indicate what we are asked to look for. Calculate the temperature to which it is heated, meaning that we should calculate the final temperature, which is theta 2. So theta 2 is the final temperature that we are asked to look for. Now, we need to think of the formula that we need to apply that will help us to find the value of theta 2. So straight away, I'm going to write out the formula to apply. So it has to be a formula that connects all these parameters together. So the formula for linear expansivity is equal to change in length, which can be represented as L2 minus L1, but we can simply write it as change in length all over the original length or the initial length, and that is L1 multiplied by the temperature difference, which is theta 2 minus theta 1. That's the temperature difference. So this is the formula that we need to apply to carry out the calculation. So let's go one after the other and see how to substitute and simplify this formula. So I'll start by writing the value of alpha, which is 2.3 multiplied by 10 raised to power minus 5, and that is equal to the change in length, which is 0.007. So I write 0.007 or divide by the original length, which is L1, and L1 is 1.8. So 1.8 multiplied by the temperature difference. Theta 2 is what we are looking for. So I write it as theta 2 minus theta 1 is 10 degrees Celsius, 10. So that's the value for theta 1. Then now let's simplify further so that we can find the theta 2, which is the final temperature that we are looking for. So now, I can simply multiply this by this. Let me cross multiply. Don't forget, this is like over 1. This is like over 1. So when this multiplies 1.8, it's going to give us 4.14 times 10 raised to power minus 5. And then all multiply by the change in temperature there, which is theta 2 minus 10. and that will be equal to 0.007 multiplied by 1 will still give us 0.007. Then the next thing for us to do now is to divide both sides. Let me divide both sides by this value here, which is 4.14 times 10 raised to the power minus 5. I also divide this side by 4.14 times 10 raised to the power minus 5. So that this value here, we cancel this value here. And then we'll be left with, on this left-hand side, we'll be left with theta 2 minus 10. And is equal to, by the time we get our calculator and divide this, please, when you are dividing, don't forget to put this denominator in brackets so that the calculator can really follow board mass and give you the accurate answer. So when you are dividing these two values, remember to put this part in your calculator, there's bracket. Put this denominator inside the bracket and then you evaluate it to give you the correct answer. So this divided by this is going to give you 169.1 as the value that this part will give to you. From there, I'm looking for theta 2. So I say theta 2 is equal to this 161. Let me write it for 169.1. When this minus 10 comes to this side, it becomes plus 10. And then finally, we have arrived at our answer as this plus this, that 10 will give us 179.1 degrees Celsius. And this is the temperature to which the aluminum rod is heated to. Hope you understood it fully. Please don't forget to like, share, and join for more videos like this. Thank you for watching.